Hi, everybody. Today is Wednesday, November 30th. So I have been gone on the last 2 days, Monday and Tuesday of this week. So today we use the time to just review lessons 1.3 and 1.4. If you were here or if you've watched the videos, you know that the lesson was presented to you in a video, and sometimes that's just very confusing. And based on the homework assignments that have been turned in to Amplify, I just wanted to go over some things and clarify. So go ahead and first things first, I want you to take this PDF, Sedimentary versus Igneous Rock student notes, and I want you to put those in good notes. We're going to go over those a little bit later and fill them in, okay? I'm going to have you pause the video, put those in good notes, and then come on back. All right, so first thing is I had the kids log into Amplify. I don't know why I did that. Done. I had them log into Amplify and go to lesson 1.3, and then I wanted them specifically to go to activity 2, screen 2, and so I would like you to do that as well. I want to go back to the simulation, and I just want to kind of talk about how igneous and sedimentary rock are formed, what materials they use, what the processes are. Just make sure everybody understands, okay? So first things first, if I want to make sedimentary rock, I could weather, and you'll notice that weathering is when the rock breaks down into sediment pieces. Now, if you look at the top left, you'll see the process is weathering, and this takes several millions of years for this to occur. If you think about the little teeny tiny pieces of grain of sand and how long it would take to accumulate enough to make a layer of sandstone, it's a lot. So again, we're just going to weather. Weathering is the breaking down of rock. And then the actual erosion is when the rock moves. Okay, so rock going from one location to another location is called erosion. And so what happens here, look up in the top left, we've got layers, and over thousands of years, those layers compact and go through compaction and cementation. There's 2 steps. I'm just going to add one more layer of rock, layer of sediment, and I want you to notice this is going through compaction and cementation. And what we're left with is you can see those 3 layers of rock, of sedimentary rock. One's kind of a dark gray, light gray, and then dark gray again. I'm going to go ahead and analyze the rock, and you can definitely see the different colors of sedimentary rock. And if I click on each layer, it tells me this first layer is sandstone. Look at the characteristics. It's made of sand-sized groups of minerals with rounded edges, and it can be many different colors. The middle layer is also sandstone, and the bottom layer is sandstone as well. Some of the models may have had shale, which is a different type of sedimentary rock, but the characteristics are always the same. The grains have rounded edges because of that weathering and erosion. So what are the materials used to make sedimentary rock? Well, it's sediment, obviously. And the process is compaction and cementation. We'll talk a little bit more about that in a little bit. Let's talk about igneous rocks now. How do we make igneous rocks? Well, first of all, we have to melt something. And so if I melt rock, you'll see that that's liquid rock under the surface of Earth. So that's called magma. And if I want to let me do cooling below the surface first. This is where a lot of people were a little bit confused with how the rock is formed. So listen, not all magma comes to the surface of Earth and is cooling and hardening below the surface of Earth. Sometimes it cools and hardens below the surface of Earth. So this is still magma. And I'm going to analyze the rock because I want to show you. Sometimes it cools and hardens within other rock, right? Because it's melted and cooled and hardened. So if I was to analyze this rock, I'm looking at this one right here. That's gabbro. And the rock around it is gabbro. The rock underneath that is called mantle rock. And this is also igneous rock. So it's interesting that as this cools and hardens, listen, I'm going to try it over here for a sec. I'm going to cool below the surface. I'm going to click this guy right here. And let's see if we get a different rock. That's granite. This is granite. So if it cools and hardens within the same, it could be. I'm wondering, it would be interesting to see if different rock forms within different rock, like if gabbro ever formed within this granite. That would be interesting to find out. So I can have magma cool and harden below Earth's surface, or I can have it cool and harden above Earth's surface, and that makes a volcano, okay? And if I was going to analyze that rock, that should be, so this is called rhyolite, and it's made of small minerals with sharp edges. Same with this, small minerals, sharp edges, and the same with this. They've got sharp edges. So all of those have the same characteristic as far as their grain shape, and then different colors and stuff. All right, so coming back to my slide, we talked about that sedimentary rock, after the process of compaction and cementation, it turned into a layer of rock. And as far as the magma, there are two things that could happen. It could either turn into rock inside other rock, or it could turn into a volcano. And the two steps for igneous rock is cool and harden. Let me know if you do not understand that. That is very important that you understand those. All right, next, we went ahead in class today and we did this model of how sediment forms. And if you've got any questions about that, let me know. You can see it as soon as you come back to class. But we just talked about how this modeled compaction, and then cementation is the process of sediment being glued together. It's glued together by minerals as the water evaporates. So what I want you to think about is if a mineral, one of the things that happens with a mineral is when it is in water and it's kind of crushed down, it can dissolve in water. And then as the water, like right here, we've got different sediment that's being laid on top of each other. And in the space between, there's water. Now, if there's no water, there's no rock that's going to be formed. So think about the beaches. Beaches are beaches and not rocks because there's no water that's being held there. Over time, those rocks get compressed together and the water that's in between them will evaporate. And then the minerals that were dissolved in the water will go back to their solid form, and they act as like a glue that holds those other rocks together. Okay? So we went back to our model, and the one thing that we needed to add to model the process of cementation was water. So I just took my spray bottle and I sprayed a couple drops of water in each one of the cups, and then we laid them aside so that we could check those in a couple days and see if we've created some sedimentary rock. We talked about the video from yesterday, how lava forms rock when it cools and hardens. Okay, so igneous rock is a type of rock that's formed when magma or lava cools and becomes hardened. We've got the three key concepts, and I've highlighted the main words there. If I'm going too fast, just pause the video, make sure that you write down the key concept if you haven't already, and then I want you to highlight the important words. That's going to help you identify what your key concepts are when you study. So key concept number 1, rocks can form in different ways. This causes them to be different types. Key concept number 2, when sediment is compacted and cemented together, it forms sedimentary rock. Key concept number 3, when magma or lava cools, it hardens to become or to form igneous rock. You are going to have to add that parenthetical phrase right there, or lava, because I don't have that on your original key concepts, I think. So make sure that you include both because it's important. We saw in the sim that magma and lava can cool and harden to form igneous rock. All right, the last thing is your sedimentary rock and igneous rock comparison. I'm going to let you fill in your blanks. And as you do that, take a look at the picture and really identify each one of those bullet points so that you can see what I'm talking about. Okay? All right. Let me know if you've got any questions. I'll talk to you when you get back.